Welcome back. So today we're going to look at some more properties of logarithms. But before we do that, I just want to review some things that we have seen in the assignments that we've been working on over logs. So remember the definition of a logarithm I gave you. It was written like this. If you have log base b of n is equal to p. This is a true statement if and only if b to the p power is equal to n. And remember, there were some restrictions. B has to be greater than 0 and not equal to 1. So what that means is b has to be a positive number. Also, n has to be greater than 0, but n can be 1. So n has to be any positive number. All right, so let's just look at a couple of these. You should know the answer to these. This is just review here. If we have b raised to the log base b of x, remember when you have a power and the exponent of your power is a logarithm of the same base as your power, you can think of them canceling each other out. And the answer would be just x. All right, so let's look at number 2 here. We got log base b of b. How do we solve that? Well, you know how to solve problems like this. If you have log base 2 of 8, you should be able to solve that. Because basically, you can do this in your head. This is your base. The 2 is your base. You're asking yourself, 2 to what power is 8? 2 to what power is 8? 3. So let's use that same concept up here. What am I going to ask myself? Well, b is my base. B to what power is b? Well, b is really b to the first power. So b to what power is b to the first power? 1. So when you got log base b of b, that will always equal 1. So what that means is if I have log base 8 of 8, the answer is 1. Alright, so this is just common sense. This is stuff that you already knew, but now I'm just writing it as a rule. So this next one, number 3, we got log base b of 1. What would that equal? Well, we're going to ask ourselves, b to what power is 1? Well, remember, we have a rule. Anything raised to the 0 power is 1. So log base b of 1 will always be 0. So what that means is log of any base, log base 10 of 1 is 0. Log base 2 of 1 is 0. Log base pi of 1 is 0. Okay? That's what that says, that rule. And rule number 4, well, if you think about this one, this is my base, b is. So if I do like the circle of life, b to what power is this number? B to what power is b to the x? Well, it's going to be just x. So when you got log base b of b to the x, you can think of these as canceling it out, and you just get x. Okay? Now this last one is a rule that we've been using a lot. When you got a log equal to a log, and both logarithms have the same base, you can think the only way these two logarithms can be equal is if a is equal to b. So you can think of the logs canceling out. A will equal B. So this is just rules that we have seen, but now I'm telling you them. All right, so I want to add to this list of rules here. So this is the new stuff. Okay? So what's important about these properties is you want to be able to go back and forth. You want to be able to go from the left side to the right side sometimes, but sometimes it's going to be helpful to go from the right side to the left side. So basically, these are the rules for how you can add, subtract logarithms here. So if you look at rule number 1, property number 1 here, you got 2 logarithms over here. So if I had like log base 2 of 3 plus log base 2 of 7. If I'm adding 2 logarithms and the 2 logarithms have the same base, to add them together, I would multiply these numbers together. So log base 3, log base 2 of 3 plus log base 2 of 7, that would equal, well, both of these logarithms have the same base. So that would equal log base 2. You don't do anything with the base stays the same. And then what you do is multiply those together. 3 times 7 is 21. So log base 2 of 21 would be the answer. This should remind you of like power rules. Because remember, when you multiply 2 powers that have the same base, what do? You leave the base alone and you add the exponents. Well, logarithms are like the inverse. So it's kind of like the opposite. When you multiply powers, you add. When you add logs, you multiply. All right, so let's look at row 2 here. Here, we're taking a logarithm minus another logarithm. Up here, we were adding 2 logs, we multiply. Here, we're subtracting, so what we do is we divide. So an example, if I have log base 2 of 16 minus log base 2 of 4, what am I doing? I'm subtracting. So I'm subtracting 2 logarithms that have the same base. So that'll be log base 2 of 16 divided by 4. 16 divided by 4 is just 4. So that'll be log base 2 of 2. And we can simplify that further. Because that's one of the rules that we just went over. That's this rule right here. You got log base b of b. What did that equal? That equaled 1. So if we go back to this one, log base 2 of 2 would be 1. Alright, so let's look at 3 and 4. Well, 3 and 4, they look like 2 different rules, but they're actually the same rule. Basically what it says is if you have like a power here, what you can do is take that exponent and move it to the front of your logarithm, and then multiply by the log. So like for example, if I have this, log base 2 of 25. Well, think about 25. 25 can be written as log base 2 of 5 squared. And then what I can do is I can use that rule. I can take the 2 and move it to the front. So I can make this 2 times a log base 2 of 5. That's what rule 3 says. And I said rule 4 is the same as rule 3 because, remember, when you have a radical, you can rewrite it as a power. Over here we got log base b of the c root of a. Well, I can rewrite that as log base b of a to the 1 over c power. The exponent on the a is a 1. The index is your denominator. The index of this radical is my denominator. And then, just like row 3, when we have a power right here, we can take that exponent and move it to the front. My exponent is 1 over c. So this will be 1 over c times log base b, just a. And then row 5 is actually the same as row 5 here. It's just an important row, so I just wrote it out twice. So if you get log equal to log, the logs cancel out. You can set a is equal to c. All right, so what we're going to be doing today is we're going to be practicing these rules right here to solve logarithms. So let's look at an example. All right, so it wants us to evaluate each expression. But in the directions it gives us, it tells us the log base 12 of 8 is this decimal, 0.8368. And it also tells us the log base 12 of 10 is 0.9226. So it gives us these two. Okay? We don't know how to find these decimals. Back in the day, before we had calculators, they had logarithm tables. And that's what you use to find logs. But today we got calculators. But I'm not going to show you how to use the calculator yet. Okay? How to do logarithms on calculators. So I'm not showing you how to do those yet. So what we're going to have to do is we'll have to try to do these by hand. We know what the log base 12 of 8 is. We know what the log base 12 of 10 is. It wants us to find log base 12 of 80. So what I'm going to have to do is I'm going to have to use the logs of base 12 that I know. I know 8 and 10. Well, what's 8 times 10? 80. So what we can do is we can think log base 12 of 80 as 8 times 10. So what are we doing here? Well, multiplying. So what we're going to do is we're going to use this rule right here. But we're going to go from the left side to the right side. We're going to rewrite it as 2 logarithms. I got 8 times 10. So 8 is like my A. 10 is like my C. So that means I can rewrite that single logarithm as 2 logarithms with addition. So I can rewrite this as log base 12 of 8 plus log base 12 of 10. Now we know what log base 12 of 8 is, and the only reason we know it is because it gave us the answer and the directions. And it also gave us the answer of log base 12 of 10. So what we can do is we can add these two decimals together to find out what the log base 12 of 80 is. So if we add these together, we get 1.7594. So that's my answer. So log base 12 of 80 is 1.7594. All right, so let's try number 2. Again, we're going to do number 2 like we did number 1. We're going to try to break it into log base 12 of logarithms that I know. I know log base 12 of 8 and log base 12 of 10. Okay? So does 8 go into 96? It does. So I can think of log base 12 of 96 as log base 12 of 8 times 12. But I don't know if this does us any good, because do we know what log base 12 of 12 is? We do, actually. That's one of the rules that we just went over in the beginning. So here's what I can do now. I can rewrite this as log base 12 of 8 plus log base 12 of 12. We know what log base 12 of 8 is. And again, the only reason we know it is because it gives it to us in the directions. So it's 0.8368. It doesn't give us log base 12 of 12, but we should know that. Log base 12 of 12 would be 1. So we got 0.8368 plus 1. which will be just 1.8368. So there's our answer. Okay, questions? Right, so let's try a couple more here. So now let's look at 3 and 4. Again, this is what they give us. They give us log base 12 of 8, and they give us log base 12 of 10. Right, so on number 3, we have a fraction. So we're dividing here, 1 divided by 144. So if we go back and look at our rules, when we divide, what do? We subtract. So what we can do here on this one is we can rewrite this as log base 12 of 1 minus log base 12 of 144. But these are not given in the directions, but these are ones that you should know. What is log base 12 of 1? Well, if you don't know it, the question you're going to ask yourself is 12 to what power is 1? 12 to what power is 1? 0. Well, what's log base 12 of 144? Well, you can do it actually 2 ways. You can think of it as 12 to what power is 144? And that is 2. So the answer to this would be just negative 2. Another way you could have did log base 12 of 144 is you could have thought 144 is really 12 squared. And then look, the bases match here, so that's why it's 2. Or you could even do this. You could think of this as log base 12 of 12 squared. We can use that other new rule that we learned, rule number 3. When you got a power here, you can move the exponent to the front of your fraction, front of your logarithm. So you could have rewrote this as 2 times log base 12 of 12. So that would be 2 times log base 12 of 12, which is 1. 2 times 1 is 2. Right, so let's do this last one. We want to find log base 12 of 0.64. Well, just like we did earlier when we had decimals, let's rewrite it as a fraction. So let's rewrite this as log base 12 of 64 over 100. So then I could rewrite this as log base 12 of 64. What am I doing here? Dividing. So I can subtract minus log base 12 of 100. But what is 64? 64 is 8 squared. So I can rewrite this as log base 12 of 8 squared. And then 100 is 10 squared. And then, like I showed you on that last one, you get a power here. That new rule that we learned, rule 3, says you can move your exponent to the front of your logarithm. So this would be 2 times log base 12 of 8 minus, we'll do the same trick here. Move this 2 to the front. 2 times the log base 12 of 10. So this would be 2 times that decimal. Log base 12 of 8 is 0.8368 minus 2 times the log base 12 of 10, which is 0.9226. You work those out, you can plug that into a calculator, and we will end up with negative 0.1716, which is our answer. So these are going to take some practice. So what I would like for you to do is I want you to try the problems on the homework. I want you to try to do, let's see, what is it? I think it's 1 through 8. So the homework assignment is do 1 through 8. Only 1 through 8. I'll show you how to do the rest tomorrow.